Welcome to the fourth lecture on ECD, Electronic Circuits Design. We are going to start low frequency response of amplifiers today, and we'll study some basics of it today. In this lecture, we will study some basic items regarding the low frequency response of our BJT amplifier. This is a BJT amplifier, and in our earlier lectures we have studied that C1 and C3 are coupling capacitors, whereas C2 is the bypass capacitor. And the reduced gain obtained at lower frequencies is due to C1, C3, the coupling capacitors, and is due to the bypass capacitor. And reduced response at higher frequencies is due to the junction capacitances that we do not connect externally, but they are there internally. Right. From the EDC course, Electronic Devices and Circuits course, we have studied that the input impedance seen at this terminal is this R1 in parallel with R2 in parallel with this capital RE and this small re multiplied with a beta, because these two resistances are on the output side, and once we see them on the input side we multiply them with beta. So this is what the Rin of this amplifier is: R1, this in parallel with R2 in parallel with beta times Re plus capital Re. Right. So this V base then can be computed using voltage divider theorem. We have this resistance and this impedance, they are in series, and we want to find out the voltage drop across this resistance, that is the voltage drop at the base terminal. So we'll write a VDR expression, voltage divider. This VDR stands for voltage divider rule. So voltage divider rule. So V base is Rin over Rin plus Jx, C plus multiplied by the input voltage Vn, or the magnitude of V base can be written as this, since this is a complex number, and we can write the magnitude of this complex number as square root of this first term plus the second term, the real part plus the real part squared plus imaginary part squared and the whole square root. So at FC we already have studied that either it is lower cutoff frequency or higher cutoff frequency, the voltage is 0.707 times the input voltage. If this at this midband the output voltage is the same as the input voltage. If it is a 0 dB gain, if it is 0 dB, V out is equal to V in. If it is the case in midband, the base voltage is 0.707 times the input voltage. Why is it and how is it? It is possible only if we put Xc is equal to Rin. Since Rin is constant but Xc isn't, the magnitude of Xc, it depends on frequency, because this is 1 over 2 pi Fc. So if we put Xc is equal to Rin in this expression, we get this, and this Rin cancels with this Rin, and we are left with 0.707 times V in at FCL. So it is, or the voltage gain at FCL is 0.707 times the voltage gain it was during mid-band, in this band. So how to compute, as the last part, how to compute lower cutoff frequency FCL? Since at FCL Xc1 and R1 are equal, but Xc1 can also be written as 1 over 2 pi FCL times C1, therefore therefore neglecting this and putting Rn is equal to this expression, and then taking FCL on the right hand side and taking Rn on the left hand side, this becomes FCL is 1 over 2 pi Rn times C1. But sometimes we include the internal resistance of the source too. If it is the case, we have to add this Rs in Rn, and then we have to multiply that sum with Cn and 2 pi. As the last part of this lecture, we have to solve a very simple example where we are given a BJT amplifier where Rin is 1 kilo ohm, C1 is 1 microfarad. C1 is, what is C1? C1 is this coupling capacitor, the input coupling capacitor. Its capacitive reactance, its value C1 is given to be 1 microfarad, and where Rs is equal to 0. The source, the voltage, the resistance of the source, the internal resistance of the source is assumed to be 0 ohms. So FCL can be computed using the formula we have just derived. This one, putting Rs is equal to 0 in this formula, gives us this expression, and then we can compute FCL equal to 159 Hertz. Right. The second thing we have to compute is the magnitude of V base at FCL. Of course, it is 0.707 times V in. We don't have to compute anything. We know that it's 0.707 times V in. And what is AV at FCL? This is very simple. At FCL, the voltage gain AV is 70.7% or 0.707 times of the voltage gain that we had during midband, or that we have during midband. So that's all for this lecture. We'll continue studying more about low frequency response of BJT amplifiers in our upcoming lectures. Thank you.